Hey, let's find our remaining trigonometric functions. And in this instance, we are given sine, and it is equal to 12 over 13. And we are told that tangent of theta terminates in quadrant 2. Terminates quadrant 2. So let's do this first. Maybe you want to think about it like this. So we're going into quadrant 2. We know to get into quadrant 2, we had to go over some amount of x units, negative x, up some amount of positive y units, and r is always positive. So I'm going to come down here, and I'm going to say, what's x equal to, y equal to, and what is r equal to? So I know x is going to be negative, y is going to be positive, r will always be positive. Sine, they've given us. So there's one of our 6 already. It's 12 over 13. The reciprocal of sine we can also get. Cosecant, we're just going to flip it. It's the reciprocal of sine. But we still need cosine. Its reciprocal, secant. We need tangent. And we need the reciprocal of tangent, cotangent. Sine is y over r. Cosecant is r over y. Cosine is x over r. Secant is the reciprocal, r over x. Tangent is y over x. And cotangent is the reciprocal of tangent, x over y. So what's our x, what's our y, what's our r? Well, we know that sine is y over r, and it's 12 over 13. So y is our 12. And our r is 13. So what is x? All we know for sure is that it's going to be negative. Let's do the math though, Pythagorean theorem. So what is x squared? We're adding it to y squared, which is 12 squared. And we know it's going to equal r squared, 13 squared. So x squared plus 144 is equal to 169. Get our x squared alone. Sorry, this should be minus 144. And that would give us 25. X squared is equal to 25. Let's get rid of our square and square root. And we find that x is equal to 5. And we know it's negative. Now it's just like any of these other problems we've done in the past. We just have to put in the information. Cosine x over r. So negative 5 over 13. Secant, the reciprocal of cosine, just flip it. Tangent, y over x, 12 over negative 5. Cotangent, we just flip it. It's the reciprocal of tangent, negative 5 over 12. All right, let's do another example. Probably 2 more examples. We'll just go down here. All right, for this example, we are given that tangent of theta is equal to negative 1/2, and that sine of theta is negative, and they want us to find the remaining trig functions. So what are we going to need? We're going to need to figure out what x is equal to, what y is equal to, and what r is equal to. And it's all going to have to fit. It's all going to be, in whatever quadrant tangent is negative and sine is negative. My next move would be to come over here and plug in my information, like because I'm going to have to eventually anyways, just basically prepare to write your answers. And this is how I did it on test also. Just write out your functions and the reciprocals. We were given tangent is -1/2, so I would just plug that in. We know that cotangent is the reciprocal of tangent, so it would be -2/1, or I should, we would just put -2. Now, this is why it's important to remember, what's y, r, and x, where are they, and you'll get it eventually. So sine is y over r, cosine is x over r, tangent is y over x, and then our reciprocals are over here. We're just flipping them. So where can I get tangent to be negative and sine to be negative? And the thing is, I don't even have to figure out what quadrant it's in. So if sine is going to be negative, we know that r is already positive. We know this r has to be positive. It's always positive. So our y has to be the -1. Therefore, if we come down here, we know that this y is our negative. X can't be negative, because if it was, then our answer would come out to positive, because a negative divided by a negative is positive. So we know that our y is the -1, which means that our 1 up here is negative. So we can come over here and fill that in. -1, and we know that x is positive 2. Now let's just figure out r so we can fill in our information. X squared, or 2 squared, plus y squared, which is -1 squared, equals r squared. Therefore 4 plus 1 is equal to r squared. 5 is equal to r squared. Get r alone, square and square root cancel, and we are left with the square root of 5 is equal to r. So let's just plug that in over here. And I'm going to just go ahead and erase this here, just in case we need the room. Now let's just fill in our other ones. Y over r for sine. So it would come out to -1, this is for sine, over the square root of 5. But we can't have that square root in the bottom. So we have to multiply the top and the bottom by the square root of 5. And we end up with negative square root of 5 over square root of 5 times square root of 5. The square roots cancel. We're just left with 5. Negative square root of 5 over 5. Cosecant, we shouldn't just flip it, because then we're just going to put our square root in the bottom again, and we're just going to have to undo it. So we're not going to do that. What we'll actually do is just look back at our information over here and just do r over y, so we can avoid that. Square root of 5 over -1, which should just be written as negative square root of 5. Cosines x over r, so 2 over the square root of 5. We have to multiply the top and the bottom by the square root of 5 over 5, and we end up with 2 times the square root of 5 over square root of 5 times square root of 5. Square roots cancel. We're just left with 5. So we have 2 times the square root of 5 over 5. And for secant, we're not just going to flip it again, because we don't want to put the square root back in the bottom. We'll just have to undo it. So we look back at our information over here, and we find that r is square root of 5, x is 2. So square root of 5 over 2. And that's that. Let's do one more. Okay, so for this problem, they actually give us cosecant. And they say that cosecant, which is the reciprocal of sine, is equal to 13 over 5. And they tell us that cosine of theta is negative. To figure out all of our trig functions values, we're going to need to figure out what x is equal to, what y is equal to, and of course what r is equal to. Let's start by plugging in what they've given us. So sine of theta, cosine of theta, these are all the things we have to find. Tangent of theta, and then the reciprocals. Cosecant theta, secant of theta, cotangent of theta, and they've already given us what cosecant is, so we just had to set it in there essentially. It's 13 over 5. We know that sine is just the flipped version of cosecant, the reciprocal, however you want to think about it. It's 5 over 13. We're just flipping it. Now, this is one of the reasons, again, it's important to remember. Sine is y over r, cosine's x over r. Tangent's y over x, and then our reciprocals are just the flipped, versions of it, or the reciprocal. Now, if cosine is going to be negative, we know that r can't possibly be negative. So x is going to have to be our negative number in order to make cosine negative. And up here at sine, we know that 5 and 13 are both positive because r has to be positive, which means y can't be negative, or sine would be, it would be negative, but it's not. So they've given us y and r, and it is 5 and 13. And we know that x is going to be negative. Now let's figure out what x is. X squared plus y squared, which is 5 squared, is equal to r squared, which is 13 squared. So x squared plus 25 is equal to 169. Get rid of 25 on both sides, and we're left with x squared is equal to 144. We take the square root of both sides, and we get that x is equal to 12. And we know it's negative. We figured that out. So it's negative 12. Now, just like the other ones, we come over here and plug our information in. Negative x over r, so negative 12 over 13. Secant is just the flipped version. We're going to have 13 over negative 12. For tangent, we have y over x, so we have 5 over negative 12. And for cotangent, we have x over y, negative 12 over 5. Alright guys, thank you for watching. If you have any questions, please leave them down in the comment section below. Also, if you have any exact problems, please go ahead and put them down there, and I'll make you a video on just how I would do it and how I would think about it. And maybe we can go through a couple different ways if that's not the way you understand it. Alright, thank you for watching.